Okay, here we are. The third tutorial on October the 2nd. And by the way, where did the people go again? I'm not sure if I can hear you or not. Hang on. Huh? Um, oh,
Test one, test two. Can you hear me?
all right, I can hear you now. That's good. Okay.
I was saying they might be doing their physics lab report because they've been talking about that on the Discord.
Ouch. Ouch, yeah. Well, I'm gonna have to work on mine sooner or later. And also there's the COE 328 we have to worry about because the third lab,
Yes.
it's a little bit painful. Alright. Okay.
Give me a headache. Oh my gosh.
Yeah, same here, same here. Yep. Alright. So hang on a moment. Let me go ahead and make sure we capture this stuff. Alright. Okay, here we go. So yeah, I can't really guarantee Discord's gonna record the voices in Discord, but at least I can hear you all. So yeah, let's begin. So first thing is I'm gonna have to talk about like the topics we are gonna cover. And what we're gonna cover today would be method overloading, mutable and immutable stuff. It could be like classes and variables. And there's variable conversion and casting. I'm sure you all learned a bit about casting in Java by the time you all reached here. And a brief thing about the heap, the stack, and garbage collection in Java. And finally, we have arrays. And there will be a live demo to actually wrap up the concepts we learned here today. So please don't miss it. All right, so let's start with method overloading. So what is method overloading? It's really similar to the constructor overloading I did like last week. So you can implement methods with the same name if at least one of the following is true. So for example, the number of parameters are different. Well, because that means it will give a different method signature. Or if the types of parameters, even though they have the same number, are different. So you may have like different order of the types or different types that you want to use. That's fine as well. And also, if the return type is different, I have no idea the fact that you can actually overload a method with different return types, but now I know. So in short, you can overload the method if it has a different method signature, and just make sure that the overloaded method has the same name as the original one. Okay? Yeah. So this is something you learned in lectures, so I don't really talk much about it, but here are some examples. So we have two methods called A. So what I want to ask is this code valid? So can anyone tell me if this is okay?
Yes, it's fine.
And why is that?
Because the return types are different and the parameters they're asking for are different too.
That's right. So yes, here in this case we have different parameter types and different return types as well. So yeah, that's enough. Well, at least having a different return type is already enough to make both signatures different. So yes, this is fine, and which means that A is successfully overloaded. Okay. So in the future, if you're making programs and want to implement the same method in different ways, overloading may be your friend here. Now, here's another one. Can anyone tell me if this is legal?
I don't think so because it has the same name, return type, and the integer. They both have integers parameters.
Yup. So basically, their signatures are the same. In fact, the only thing I changed are the parameter names. But seriously, the names don't really matter. Parameter names actually, because as long as both of them have the same like parameter layouts, like only one integers for both, then that's not valid. And since they have the same return type and the same name, yeah, it's like making the same method twice, and that's not good. Okay. Well, that's about it for like method overloading. Really simple because all you need is the same name. Where's the laser pointer? So you only need to have the same name, and you only need to have a different signature, like the return type or the layout of your parameters. So that's it. That's method overloading for you. And I'm not gonna dive into too much of it. We're gonna dive into a lot more in the live demo. Okay. So that's already covered. So yeah, another thing we learned in lectures is telling the difference between mutable things and immutable things. So here's how that works. So mutable means that the maybe an object's state variables can be changed after creation. So you can change something, like how our DNA can actually mutate. So yeah, it's kind of derives from mutation. So, for example, we can use setter methods to change these things. Immutable, however, means none of the object state variables can be changed at all after creation. So, one way you can achieve this is to provide no setter methods in the class. Meaning it implicitly tells you that no, you cannot change anything in that object and you should never do it. Another thing is you can also make all of your state variables to be final. So what the final keyword does in Java is that once it's initialized, maybe you assign it a value, it's gonna be constant and it's not gonna change afterwards. So it does not allow changes to it after initialization. This is really useful for constants, which I'm gonna talk about later on, because well, sometimes we just need those variables to stay still. So here's an example. Is this class mutable? And can anyone explain why?
It's mutable because you can change the value of some int with the setter method.
Correct. And yep, that's good. That's good. Perfect. So, that's true. It is mutable because why did I say yes? What the hell? Well, it's mutable. It cannot be both. So I'm gonna have to change this so that I can make it clear to like literally anyone else. So it's mutable because you can change the set. You can use set int to change some int. Means you can mutate it. Okay. All right. Let's move on. The next thing is
Caleb.
Yeah. Yeah.
Sorry to interrupt, but you're not sharing your screen anymore.
Oh no! Oh man, what the heck happened? What the hell happened? What? Oh, sorry about that. Hang on. There you go. Yep. So let me go ahead and like show you what I changed. I just changed the word from yes to mutable because that sucks. Yeah, that was my mistake here. I actually hastily made this slideshow because I had a math midterm as well, and it drove me kind of nuts. So yeah. Okay. Here's the next one. Yes, I'm gonna interrupt this tutorial to bring you some PCS 224. So here you go. I hope this will give you some more PTSD. So the thing is, however, all I'm asking is this thing is there something illegal in this class? Anybody? Take the time to read it.
You set work function to final, but you have a setter method.
Correct.
That's illegal, right?
Yes, that is illegal because Because the thing is, the work function is final, which means it's gonna be constant throughout its life. It cannot be changed. So that is why you don't put a setter method for this thing. And thinking about it, a method cannot change its work function. I'm not sure if that even works. So yeah, I'm not sure if a method can change its work function, but as we know right now, I think it's always a constant. So that's me though. Okay, so here's this. This is constants in Java. So there is no constant keyword in Java, mind you, because that's kind of a C# thing and maybe a JavaScript and TypeScript type of thing if you have programmed in these before. So a constant in a class is basically a variable that is not changeable or not mutable throughout the entire class. So even if you're doing it in a constructor, you're not supposed to change that. Okay? It always stays constant. It always stays the same. You don't get to determine that in a constructor. Okay? So in order to actually make constants, what we can do is to use static and final behind the variable that we want to make constant. Okay? If you have programmed in C# before, I'm sure you have seen like the constant keyword, and you can access that through maybe the class itself. I'm not sure how C# constants really work that clearly, but I know that it's really I know that using static final, it's maybe really similar to how C# works with these things. So here's an example. Gravitational acceleration, which is always equal to 9.81 as we know it, is static final, which means it's always going to be a constant throughout the class. Another one we sometimes need to use would be Coulomb's constant. I call it Coulomb K because its symbol is also K, and which is also 8.99 times 10 to the 9th. Okay, and yes, if you have noticed, yes, I'm using the exponential notation here because that is how we because that's how we write scientific notation. This is just one way we can write it instead of using like a multiplication operation. All right, let's move on. That is one use of final, the final keyword in Java. So here's some things about the final keyword. A final variable will not allow any changes to it, as we discussed. A final method will not allow itself to be overridden. That is kind of like a polymorphism thing, in my opinion. I may have to look into that later on, but I think I'm confident that that's a polymorphism thing. Like you can override a method or make it virtual or something. I don't know. Like you can override a method by maybe having that original method be virtual or abstract. That is a polymorphism thing again. Now, finally, a final class cannot be extended to inheritance. That is a future topic, and you're gonna learn a bit of that once the first midterm is done for. So yeah, on inheritance, very important, but if you make the class final, it just doesn't allow itself to be extended. Okay, any questions here?
I have one question.
Sure.
What does the static keyword do again?
Static means instead of accessing it through, how should I say it? Instead of accessing it through like an instance of an object, like how we create like the new objects thing, instead of accessing those variables from there, you access it directly through the class itself.
Oh, okay.
Yeah, so how I would write how I would access static variables in, like, for example, some constants is that I will first type the name of the class. No need to make new objects from it. I would type some constants, okay, and then add a dot, okay. And once you have the dot operator to dive into the class, you just write the static variable's name as long as it's public or something. That's it.
Okay,
Yep.
thank you.
Yep. Very useful for constants and very useful for methods that do not want to use a constructor. Yeah. Some classes don't really like using constructors. I've seen them, and yeah, that's why we have static, to make sure that it's a class-wide thing. It's not just for an object. Okay, I'm gonna move on. Okay, so that's a bit too much. So, variable conversion and casting. Let me go ahead and go here. So sometimes we want to treat a variable of a type as another, and that is called casting. Okay, that is covered in lectures, and there are two types that I think that were covered in terms of casting. So widening conversions converts a variable of a smaller type to a larger one. For example, you can actually turn an integer to a long. Okay? Yeah, I think in C we have done this before. Because, like, there's the issue called integer division, and yeah, that kind of sucks. Yeah, sometimes it sucks, sometimes it's useful. Another one would be narrowing conversions, which does the opposite, which is larger type to a smaller one. Bear in mind that this means it's gonna lose some information. Like, if you're turning a double to an integer, you're gonna lose the fractional part of your number, okay? Unless that's what you want, because of, like, requirements and stuff. Yep. Yeah. So here's how you cast the value. Just like in C, you just put the desired new type of your cast behind, like, in front of your target's variable. So you can see the red box that I have the division, which is like the proper way of doing division of, like, 1 divided by 2. We need to convert at least one variable to become a double, so that we will retain our decimals. Okay. So here I have two operations using the same operator, the division. Hang on. And one thing to note is that the int division does not have a cast. Okay, there's no casting in this one, but division has a being casted as a double. Now the results of these two operations are actually different, even though they use the same operator. Why? Because integer division throws away the remainder. Yeah, it throws away the fractional part of your division. While the double division, which is the normal type of division, uses decimals, since it stores decimals. Okay? So yeah, you can see it there. Even though int division is a double, we evaluate the right side first. Okay? So yeah, bear in mind of integer division and be really careful when you're using that. There are cases where you have to divide two integers to get a decimal number. Yeah, use casting. It works. So, I'm going to move on to the next one. So, here's this. It's maybe tricky for some of you, but I want you all to get the two outputs for y1 and results. So, anybody? Oh, and yes, you can use a calculator. Don't worry. Just use a calculator, plug in the numbers. Just bear in mind of some data type issues and all that. Okay? Take your time.
I got 20 for y1 and 2.22 for the result. I have no idea if that's right though.
Okay, so let me go ahead and actually, I'm gonna go ahead and like evaluate this on the slide. Okay, so C divided by B. Okay, so that's 7 divided by 3. But since this is integer division, mind you, we're still using integer division because all of these are integers. Okay, if 10 has like 10.0, then that would be a double. But right now, we are using integer division. So 7 divided by 3, that makes 2. And then multiply that by 1, that makes also 2. And multiply that by 10. So that would make 20.0. Because we're casting it as a double. We are casting the whole right side as a double. But we're evaluating the right side first. Okay? So the first one is 20. So then, since we need to use y2, might as well do that. B divided by C, so that's 3 divided by 7. I'm going to say 3 over 7. And just in case, I'm going to write that as 0.43. Okay? And then y2 divided by y1, so this is 20. So 0.43 divided by 20. Multiply that by E. Fun facts, that is actually an Easter egg because that is the like the first three decimal places of E. And multiply that by C, which is 7. What you get is first I'm gonna get 0.43 divided by 20 times 2.718 times 7. So, okay. So I also got like approximately 0.409. I'm not sure if that is what it is, but let's see the answers. Okay, so I actually got these from Replit, but it's really close, really. Because one thing to note is that the operation B divided by C for y2 stores more digits than what's shown here. But yeah, you're supposed to get 0.4077 if you put it on Replit, okay? Yeah, so the first one is 20. Of course, you got it right because that's integer division, so all your fractional parts are erased before you cast it as a double. Then you have y2. Why did I write y2? Well, okay, so that is y2. And then you just plug in the numbers for result, and that's about it. Yeah, that's it. And let me go ahead and use an eraser, and let's move on. Yeah, so this was a rather complicated example, but it may be what you need to do on the midterms. Trust me. It might be something you will see on the midterms, but maybe not as complex, maybe as complex. Who knows? Another thing we covered so far would be the heap, the stack, and garbage collection in Java. That is some theory right here. And before we move on, any questions on casting or something like that? Going once, going twice. Okay. Oh, anything?
I was just gonna say we're all good.
All good? All right then. Let's move on. So, some things about the heap, the stack, and the garbage collection in Java is that firstly, the memory, like the information of objects that will be used are stored in a heap. You can search up the data structure called heap. This is a data structure, and we may be learning this in the next semester. So keep your eyes peeled. And local variables and parameters in methods are stored in a stack. A stack is like a stack of plates. It's like last in, first out. Okay? So the latest thing you add is the first thing you take out. Okay? So that's stack. It's useful in some other algorithms as well. So again, keep your eyes peeled on these things. They're gonna be mentioned in our next couple of courses. And trust me, they will become nightmares later on. So, another thing is, since Java is a garbage collected language, any memory that becomes impossible to access, like, I don't know, you set a variable to another object, but then that old object will be gone. Uh-oh. Which means, the garbage collector will automatically clean up your memory by removing all those unused objects from existence, so that your memory can still become free and we can process more stuff. Okay, no need to worry about freeing up memory unlike C. And yeah, that's about it. This is something I'm not gonna cover too much of because I don't really feel the need to. It's something you will see, and it's something covered a lot in the lectures. So review your lecture notes for this stuff for details. Like, yeah, that's it. All right. So arrays. This is very important because I'm sure that we have seen this in CPS 125, but how we work with this is a bit different here in Java. For one, I forgot to tell you that there are no pointers. No, seriously, there are no pointers in this thing, and that means we don't have to. That means we are not allowed to actually change variables using other methods. We're gonna have to find other ways around that. So, still, arrays do allow you to store multiple things of the same type using a single variable. So yeah, that's a C thing as well. And the type you can store in an array can be a primitive type or an object. It depends on the data type you mentioned when you declare your array. Okay? Just like C. It's very similar. And even the indices are similar. It starts from 0 to the number of things minus 1. Okay? I mean, seriously, there's nothing really different aside from like aside from the libraries that actually support these things that will make things better for us. So just like C, you can access your array looking like this. But don't use pointers because they are useless in Java. Okay? So any questions regarding the small things of arrays? There are more examples later on. Going once. Going twice. I suppose we're good then. Okay? So, about initializing arrays, this is okay. So you define the type of array, you write the name of your array, and then you add the 2 square brackets to declare that it's an array, okay? And we set that equal to an array of 4 elements, 10, 20, 30, and 40, okay? This, however, unlike C, it's also okay. C is much more rigid. C doesn't allow you to declare those array brackets next to the type name. Yeah, it's really surprising, right? Well, these two work the same way, okay? We are declaring an array of integers, and there are 4, and we use 10, 20, 30, and 40. We can initialize them just like that. Just like how we do it in C. Okay? Another thing is you can also initialize arrays looking like this. Yeah, so you can actually initialize an array with the new int array thing as long as you mention the size, okay? So once you have initialized your array like this using the new method, well, you have to allocate each element by yourself. It's not gonna be allocated for you. Well, if it's an object type, the object types will have all default values to be null for each element. For primitive types, however, it's just like before. when I mentioned this, in the case of an integer, it's 0. I think my connection's a little bit bad. Okay, there you go. I think it's better now. So let me try this again. So in the case of integers, we are gonna default all the elements in the array to be 0. Okay, so we have 0, 0, 0, 0. So 4 zeros. And for other data types, you can look back on the first tutorial on the default values when we initialize primitive types in classes. It works the same way. Okay, so I actually allocated some integers here. We have 10, 20, 30, 40 as usual. So yeah, this will end up making the sum array have the 4 elements with these 4 numbers. Okay. Fun fact, I'm not gonna actually make the tutorial too long because this is made in haste for one, and for two, I really need to take some rest and finish all of my remaining work for tomorrow. So yeah, I'm not gonna make the tutorial as long, but I will be here for questions. I may as well just stay there just in case people want to jump in or something. All right. So yeah, as I noted, make sure that you allocate your values for each element by yourself using separate statements, or use a for loop. Yeah, a for loop can work. All right. So let's go ahead and make something out of these concepts. Okay, I'm going to actually I'm gonna have to speed up some of the concepts here because we've already done that a lot of times. But just follow me, and I'm gonna actually open up my NetBeans so that you all can see what's going on. All right, so here we go. Let me go ahead and share my screen. Okay, so right now we have the person class. We first need to give the person a name, and then we're gonna have the x and the y, and we're going to implement an overloaded method. Okay, and that is called distance2, and it will have we're gonna implement that in 2 ways. One uses an x and y coordinate to specify some location that a person may not be there. So we're gonna get the distance from where the from this person, from the current person's location to the coordinates x and y. Okay. And also, we can use the same distance2 method to supply to get the distance between this person and another person with the parameter p, which is a person. Okay. Now, I'm not sure if you have done this in high school, but there's this thing called the distance formula. Okay. And the distance formula returns a double. And it returns, we're gonna use that to determine the distance. And for square roots, we're gonna use math.square root to get the square root of some number. And also, we may need to use casting for that. Okay. So yeah, let's open up the NetBeans IDE and let's get started. So the first thing is I'm gonna make a new project. I'm gonna use this new projects button, but you can use the file new projects as well because it's there. I'm gonna use Java with ant like last time, and I'm gonna use a Java class library. Okay, next thing is I'm gonna first get back to COE 318, and I'm gonna go to my workspace. I'm gonna open that, and I'm gonna call this tutorial 3, I think. Is it? Hang on. Yeah, okay. So this is I'm gonna call this tutorial 3, and I'm gonna finish so that I can create my project. Then I'm gonna follow how the lab creates their files. So I'm gonna right click and I'm gonna use a new file. And I'm gonna use a Java class, okay? So I actually forgot something, which is to use the magnifying glass, but by now you should be able to find where these things are. I'm gonna go to Java and use Java class. And I'm gonna call this person, okay? Now, for the package, I'm gonna call this tutorial3.people, okay? So, what I wrote here in package is tutorial3.people. All right, if you are new here and you just came, hello, and welcome to the third tutorial. We are just making a project that actually, how should I say it? We're making a project that determines distances of 4 people. So here is what we're making. I think I might as well like leave this window here, but yeah, I may come back to it later. Just follow along for now on NetBeans, and you may learn some things about arrays and method overloading. Yeah, and maybe casting as well, because we may use that. So yeah, once again, I have my oh, what's up? Anything? So anyone wanna?
We're all good.
We're good?
Yep.
All right, let's move on then. Once you all have your name and the location of your project, I'm just gonna click on finish. Make sure you specify the package name as well, because it's gonna create one for you. There you go. See? I think I might as well like use a. I'm gonna use a magnifying glass. Why not? Hang on a bit. Okay. So here we have the tutorial3.people, and I'm gonna also zoom in so that you all can see. So the very first thing we want to do is we want to make the state variables which are the name, x, and y. So x and y are just coordinates of the person. So let's make them. We're gonna make them all privates though, okay? First, let's type private string name. So that creates the name state variable, which is a string. I mean, duh, names are strings. We always use strings for names, of course, because, you know, letters and all that. Okay, the next thing is we need to make a private double, which is, you know what? Hang on. Thinking about it, I think if you want to maybe practice some casting, you can use an integer, but I know that we always use double to store coordinates, and for a good reason, because not everyone's gonna stand on a lattice point on the grid, okay? So we use doubles for our coordinates. Maybe I was wrong about the casting possibility, but I don't think we're gonna use that. Let's see though. The next thing is I'm gonna use y to represent the y coordinate. Okay, so that's so those are your 3 variables, and I think we might as well create oh yeah, it's unused, of course. So the next thing is I'm gonna create a constructor that actually makes these 3 that initializes the object with these 3 values that we will supply. Yeah, okay, let's do that then. Let's go ahead and make this method public, and we're gonna use the class name as our method name so that we can create the constructor. I'm gonna first first I'm gonna give that a name, and then an X, and then a Y. So all these three parameters should match the names in the state variables, because we're gonna use the this keyword to reference the objects itself. Okay. So first thing is I'm gonna type this dot name is name to assign the name state variable to the name we supply. And then this dot x is x. Oh, what on earth did I just type? This dot x is x to assign the x. And the same thing to the y, which is this dot y equals y. So there you go. That's a constructor. We're not gonna overload it because I see no use in that. So if you want to, though, go ahead and do it. And the next thing I'm going to do is I'm going to make the getters and setters, okay? We're going to need to we're going to need to make those because we're going to maybe change them later. So I'm going to first use the getter. I'm going to make the getters, so I'm going to first get name to get the name of the person. So this, you should, oh, that's not a double, that's a string. Okay. So first, we write public string gets name to get to use for the getter. Okay. And then, what we're going to do is we're just going to return this object's name. I mean, simple as that. We can also set the name as well, just in case you want to have some fun with it. And then I'm going to use the name as the name of our parameter, because we can take advantage of the this keyword to do this stuff. And one thing I forgot to do is to like make the return type the void, because we don't need to return anything. We're just setting stuff. So, that's the getters and setters for name. We're gonna do the same for the x and the y, okay? And no, we are not gonna use vector2 because that is a rather advanced thing and I don't want to use anything new as of now. I'm not sure if vector2 even exists in Java, but if it does, let's not use it because you know, I just want to make it simple. Okay. So, the next thing is we have the getters for x. Make sure the x this time is a big X because we're separating the word get and the word x. I'm going to return this dot x as a result of the getter, and I'm gonna do the same thing for the setter. Make it a void set x, and then take in a double called x and just make this dot x equals x. I'm not gonna care what they put in there because coordinates can, in theory, are limitless. So, you know, there's no way that we're gonna restrict what coordinates we can use aside from, you know, restrictions set by the double type. Okay, now let's do the same for the y. I'm going to copy and paste and change the get x's to get y. This dot y equals y. There you go. And I'm gonna return this dot y here. Make sure that if you're using the copy and paste method, make sure that you are make sure that your variables are the right ones that you're trying to change or get information of, because you know you don't want to make weird mistakes here. Well, of course, we can, but we just have to debug it anyway. Okay. Any questions on the getters and setters? Going once, twice, and let's move on. Okay, so I'm assume that you all got used to making getters and setters at this point. Okay, so I'm gonna move on now. Okay, let's see what's next. the next thing is I want to make distance 2 the method. And I'm gonna use 2 implementations. So this is where method overloading comes in. So the first thing is I'm gonna make a few new lines, and I'm going to make the first implementation, which uses 2 coordinates to define some point. I'm gonna use public double distance 2, and what we're gonna take in would be double x and double y, as mentioned here. Okay. Let me go ahead and see if there's anybody. Oh, okay. That's just weird things. Okay. So what's next is that I'm gonna need to get the distance between 2 points. And as we know, we have the distance formula. And what we're gonna do is we're gonna return the distance using the distance formula. So I'm gonna make 2 variables to store the delta x and delta y because we're gonna need to use those 2 to determine the distance. So let's start with that. Double delta x is equal to this dot x. Oh, or actually I'm just gonna use x minus this dot x. I'm gonna use the formula x2 minus x1 so that we can make things a bit better to interpret. Then I'm gonna get delta y, which is equal to y minus this dot y. Oh, not x, y. Buddy, come on. Come on, NetBeans, you can do better than this. Okay. So, how are we going to actually guess how do we get the square roots though? To do that, I'm gonna first type the class called math. Math is a class that houses some useful functions in the form of static methods. So I'm gonna get math dot square root, which uses a double. Okay, we're going to, instead of y, however, we're gonna use delta x times delta x, and then plus delta y times delta y. Okay. Now another way you can write this is to use math.pow, but I'm not gonna do that. Okay. And I'm going to store that in a variable called distance. Okay. So finally, what we're gonna do is we're gonna return distance. Okay. So any questions regarding that? Going once, going twice. I'm gonna move on now, okay? No questions so far. If you want me to like slow down for a bit, just let me know. Otherwise, I'm gonna move on now. So, here's what's next. The next thing is that I'm going to implement another distance 2 method, but this time I'm gonna overload it with another set of parameters, there's only like one parameter for this implementation, which is person. We let p be the person. Okay, so in order to cut ourselves some slack, what I'm gonna do is I'm gonna return this dot distance 2, and I'm gonna use the x and y implementation, but in order to get these 2 things, I can use p dot get x, because remember, a person has the get x and get y getters, right? Well, we can use them here. There you go. That's it. That's how we do it. Yeah, there's a reason why method overloading can be really useful. Okay. I think there are other ways to actually write this, but yeah, that is my way of doing it, and you can use yours as well. But in a nutshell, I'm using the first implementation of distance 2, except where we instead of just a bunch of numbers, we're gonna use the person's x and the person's y. Okay. Yeah. Any questions here on overloading the method? I'm gonna move on now, okay? Since there are no questions. Okay. So that's pretty much what we need to do. Another thing we have to do is we want to make a tester class to practice some concepts of arrays, okay? I'm going to do that right now by making a new class. So I'm gonna right click on the package and go to new Java main class, and I'm gonna call this person tester. Okay, so that's the name, and I'm going to click on finish here. So make sure that your name is spelled correctly. Otherwise, you're gonna have to use F2 on the wrong name to correct it. I'm gonna click on finish, and what I'm gonna do is I'm gonna take a look at what we need to do on the slide. So in the main method, I'm gonna make an array of 4 people. Okay, so I'm gonna use a for loop for this one. You can use different ways to do it, but I would rather we use a for loop, and we're gonna assign the random coordinates. You can use like a formula to determine your coordinates, or you can also just use math.random. That is, if I know how to. If you know how to as well. So, first thing is I'm gonna need to I'm gonna declare a person array called people, and we're gonna let that equal to new person array of 4. Okay? So this is the keyword new method to create an empty array but with 4 elements. Okay. So yeah, nothing really special here. Other than the fact that we're using the objects type as the target type of our array. No biggie, because Java can handle this stuff. Okay? I'm gonna move on next. Feel free to interrupt me if you have any questions. So the next thing is I'm gonna give them random locations. Okay, let's do that. I'm going to use a for loop. FOR. I'm gonna use this implementation. And I'm going to be I'm gonna make sure that it goes from 0 to 4, and I'm gonna make the okay, you know what, that's fine. So I'm gonna make the counter I. We're gonna use the I shortly because for loops allow us to do that, so we will take advantage of it. So the next thing is I'm gonna type people, and I'm gonna get the index we're gonna assign using the same square brackets operator, and I'm gonna put the index I inside. Okay, and I'm going to let that equal to a new person, and maybe what I should do is I should like also make a a list of names. So I'm gonna make a string array, and I'm going to call it names, and I'm just gonna use the curly bracket to give it give it an array of names. So I'm gonna call this thing John, and I'm gonna call this Gracie, and I'm going to call this how should I call it? Aaron, and I'm also gonna call this who should I call this? Stacy? Sure. All right. So these are just random names that I thought of. And there you go. So I'm first going to call names, and I'm going to use names index I. Since there are only 4 names, it has the same number of things as the people array, so I'm fine with that one. The next thing is I'm going to also assign an X and a Y. So let's see if mass.random has anything that can get us to okay, hang on. Let's see if Java has something that's maybe useful. Let me go ahead and open up Firefox. Java random range. Oh, we may need to use the random objects, but You know what? Yeah, I'm gonna actually You know what? Sure. I'm gonna use the Java util.random. Now, bear with me here because I'm gonna need to import another package into the mix. So I'm gonna delete this. And I'm going to type import java.util.random. So there you go. So import java.util.random. Oh, hang on. And make sure you do your imports after the package name so that you don't like mess with the IDE. Okay? So all right. I'm gonna also make a new random object. I'm gonna call this random equal to new random. I'm gonna let the defaults decide the seeds and all that. Okay, you can read more on Java util random, but it's really useful since we have a range of numbers we want to work with. So I'm gonna use random dot next double, and I'm gonna range that from negative 9999 to 9999. And I'm gonna, you know what? Instead of putting it here, I'm gonna assign this random number into X. Yep, that is legal. Don't worry. It's just a local variable for the for loop. So I'm gonna do the same to this. Oh, what's going on here? What's going on? Oh. Hang on. Dang it, Java, why are you making like random numbers within a range so hard? My goodness. Okay. All right. You know what? Nah, let's not use that. Okay, so that was a little bit of my mistake on my part. I did not notice that this is not supposed to be how it works. But I think I have an idea as to what to do. So I'm gonna use mass dot is there a there's a round. Okay. I'm gonna round a random number and a formula I'm gonna use is just have first I'm gonna use the mass dot random, which returns a number from 0 to 1. I think 1 is actually not inclusive. And I'm gonna multiply this by let's see. I'm gonna multiply this by the maximum and the minimum. So I'm gonna make it let's see. Maximum is 1,000 10,000. You can also make it like a million or something. You know what? Sure, I'm gonna make it a million. And I'm going to make the minimum -1 million. Okay? Now, there's a better way to do this, which is to just make ourselves a method that actually does this thing. So, I'm gonna type public static, and then I'm gonna use what is it? Double. And I'm gonna say generate random. And I'm going to have a minimum and a maximum. And then what I'm gonna do is I'm gonna copy and paste this stuff. And I'm not gonna round it. Now that I think about it, because round just rounds it to an integer or something. So I'm gonna keep the end open-ended, but now what I can do is I can use max minus min like this, and that would be fine. Okay? You can do it like this. You can just look at my code for now, and like to clear up any confusion, I'm just trying to make a method that generates a random number. Okay? I'm gonna write generate random, and I'm gonna generate this from -1,000 to 1,000. Okay? And I'm gonna do the same thing here. If you want to, you can even use like you can also use 1 million. Why not? Anyway, yeah, if you want to use a smaller range, however, just use 100. That's fine. Yeah. So yeah, the ranges of your numbers can be anything you want. Okay? Yeah, I'm gonna move on now. Now I have my x and my y ready. I'm going to put those two coordinates into my constructor call. And there you go. This is your new people object, or your new person object. Okay? So now, what I'm gonna do is I'm gonna make a comment saying this creates some person objects, and then now I'm going to print out some stuff about them. So the next thing is I'm going to make the program print the location of this person, the distance of this person from the origin, the distance of this person from a single point. For me, it's like 2718. Yes, that's another Easter egg pun that I really like to use. Because look, it's 2718, 2.718. Oh, great, it's the E again. So each person's distance from, and also we need the person's distance from the first person in the array. And if we are on the first person themselves, we're gonna make the person I'm gonna make it hang on. I'm gonna make the distance between you and yourself be 0 because you are in the spot that you are in right now. So you don't have to walk a distance away, you just stay still. So, let's go ahead and print out these 4 things. So I'm gonna copy these requirements here, and I'm gonna go back to NetBeans. And I'm going to use a block comment to house all these. Okay, I'm gonna make this thing look good. Oh, whoops. Okay, so here's how it works. There you go. So now, what I'm gonna do is I'm gonna make the for loop. So I'm gonna use the same thing as well. I'm going to use this time I'm gonna use J. Why not? I'm gonna use J from 0 all the way to 4. Not inclusive, and I'm gonna keep adding 1 because that is a typical application of for loops when used with arrays. Maybe some algorithms don't really need all the elements, but some do. Okay, let's move on. The next thing is what I want is I want to print the person's location. So I'm gonna print first I'm gonna get the name of the person. So I'm gonna make myself a bit easier, make things a bit easier by having a variable that references the person. So I'm gonna have P represent the person, and make sure you use J if you're using J in your for loop. So P will be our current person. Okay. So first I'm gonna get the name so that we are not rude to them. So now I'm going to write something like p.get names location is. You can see that I'm actually using an escape character here because single quotes are sometimes used in strings, which may cause some trouble when you are typing them as usual. So make sure you use escape characters if you are trying to put special characters in your strings. So this person's location is, and I'm gonna open up a bracket, and then I'm going to add p.getx, and then and then I'm going to add a comma and a space. You don't need the space really. And then I'm going to get the other coordinate, which is y, and that is going to then be concatenated with this. So here's how it works. You can also use printf if you don't want to use concatenation looking like this mess. But what it does is, for example, this name's location is, and then we get the x, and then get the y. Okay? Get the x, add a comma, and get the y. And you'll see this in a nice coordinate format. Okay? So the next thing is that we need the distance from the origin. So I'm going to copy and paste what we're gonna print, and I'm going to say okay. I'm gonna also before that, I'm gonna also make a variable to get the distance from the distance to the origin. So I'm gonna type double distance to origin equal to p dot get. Oh, no, it's distance to. You can also make the name distance to get distance to, but I'm gonna use distance to make it distinct from the get to methods. So distance to And I'm going to make this 0 and 0. And then I will also do something like distance to point, which is p dot distance to 27 and 18. You can also put that as a constant using the final static keyword, but it's your choice. And finally, what we want to do is we want to guess the distance from the distance to the first person in the array. So I'm gonna get distance to person 0 equal to p dot distance 2. Now this one we're not gonna use the person's x and the person's y. Instead, we're just gonna use people 0, and that's it. So we have all the information we need. So now what I'm gonna do is I'm going to compile all this information into some nice messages. So we're gonna first print where the person is, and then I'm gonna print where the how far the person is away from the origin. So I'm gonna say p dot gets name is maybe distance to origin units away from the origin. And then I'm going to do the same thing to distance to point. So I'm gonna make the distance to origin to distance to point, and I'm going to say something units away from 27 and 18. You can play around with this if you want. And finally, I want to also go to person 0, and I'm going to say something like distance to person units away from, and then instead of writing the first person, I'm going to write the name of the first person. So I need to concatenate this with people index 0 dot get name. You can put this in a variable if you want. And that's it. I'm gonna save this. Okay. Any questions so far regarding the implementation of the person tester class? I know it's a bit messy, so let me know if there's something wrong with anything. Yeah? Going once, going twice, going 3 times, and I'm gonna move on. Okay? So what we're gonna do next is we are going to run the program, because that's all we need to do. And I'm gonna run this. Use the person tester as your main class. And hope for the best. So here we are. We have all these messages. And I'm gonna zoom in here. So the first one is John, whose location is right here. And he is this many units away from the origin. And this many units away from 27 and 18. And John, of course, being John himself, is 0 units away from himself. Now, let's use Gracie. Let's see Gracie. Gracie is at 107 and 181. And, oh, wow. I wonder why, but, oh dear. What happened to, like, oh, wait, hang on. Why is this not like generating the right numbers? Hang on. Okay. Hang on. One thing I find very, very suspicious is why is the okay. Yeah, the random implementation is not really working, so I'm gonna take a look at how we can like use random in Java. Mass.random. What does it return? 0 and 1. Oh, I think I know why. We want to also subtract that by the minimum. I think. So in that case, since this returns from 0 to 1, I'm going to or actually is it like adding the minimum or subtracting the minimum? I think it's adding the minimum. But it's very hard to say. Just temper around with the random function and let me know. There you go. I think this works now. Phew. Okay. So yeah, I think adding the minimum works. Okay. So in that case, what I'm gonna do is I'm going to just use adding the minimum. And yeah, so John's still 0 units away from himself, but this time the coordinates look better now. Yep, so Gracie, wow, she is kind of on the bottom right side of the Cartesian plane. Aaron is near the top left, but not really. And then there's Stacy, whose location is also top left. Okay. Okay, so yeah, that's it. And maybe you can like run the numbers to verify that it's correct, but I think it's correct if it works like that. Okay? So I'm going to actually run the numbers so that I can see if it is like if it is correct. At 17.1618 squared. Is this right? Yep, that works. And then we can also have yeah, I think this works now. Since like John should be that many units away from John, so that works. Yep, I think that's all good. Yeah. So what do you think, you all? If you have actually followed along, what do you think? What do you think of this little exercise? It's okay? Alright, so just to let you know, I'm not sure if like there is a midterm like next week, but for next week, I think I'm gonna actually stop tutorials in the next week because of Thanksgiving. So yeah, rest well this week. And just make sure you do your studies for PCS 224 because we have a midterm the day after Thanksgiving. Who plans these dates anyway? And yeah, that's it. I think we are done now. Does anyone have any questions so far?
I have no questions. I just want to say thank you.
No worries. Have a good day. By the way, where are the people again?
No clue.
No clue
No
either.
idea.
No idea either. I have no idea why like not many people are showing up, but yeah. I really hope more people will show up though because they really need this.
Yeah.
Yeah. Anyway, yeah, I'm gonna stop recording here, and recording is gonna stop in 3, 2, 1. See ya, people.